Okay, so we are now working on day 2 in your trig unit note pack, and takes us to the 4th page of the note packet. These are your extra questions that you can do in the book for practice. We're also going to do a lot of unit circle practice in class today, as well as understanding really what that means. Sorry, Wednesday and Thursday we're going to be doing that. And unit circle is something you're going to get quizzed on over and over and over and over again until everybody in class gets 100% on it. It's a really important concept in trig, and you all need to be very versed in it. So, okay, so let's do some terms that we need to know. So when we're discussing angle and angle measure, we're talking about within the unit circle. We are using the triangle information that we have, but it's being placed onto a unit circle that basically is this entire circle that would come around the quadrants that we have in a coordinate plane. So if we started on the x-axis, we would have 0 degrees have gone by. If we go up to the y-axis, 90 degrees have gone by. If we're going counterclockwise, back down to the x-axis, 180 degrees have gone by. Back down to the y-axis. On the negative side, that would be 270 degrees has gone by, and 360 completes a full circle. So when we talk about the initial side, we're talking about where the angle begins counting, basically. Where the angle begins. That's for counting purposes. Okay. Usually it is there on the x-axis in the first quadrant. Usually. Not always, but usually. The terminal side means where that angle opens up and where it stops. So this would be the terminal side. So where the angle ends. Okay. The vertex is usually going to be at the origin. Usually at the origin. And what it really is the measure there of the angle. Okay. A standard position is an angle whose vertex is at the origin and whose initial side is the positive x-axis. So this is usually your starting point. You can move off of the standard position, obviously, but normally this is where you're going to start. Okay. So you do have positive and negative angles when you're dealing in the unit circle. Positive angle means that it is going counterclockwise. It is starting at 0, moving up to 90 to 180 in a positive direction, gaining degrees as it goes around. So 225. So you can kind of think about the degrees would be between 0 and 90 would be in the first quadrant. 90 to 180 would be in the second quadrant. 180 to 270 in the third quadrant, and 270 to 360 would be in the fourth quadrant. That can come around again. Then it starts over again. So 360, add another 90 to 450. Yes, you will see degrees higher than 360 in the unit circle. 450 to 720. Not 720, sorry, 540. Skipped ahead a whole quadrant. 540. 540 to 630, and 630 to 720. Those are all degrees that are possible. Okay, they're moving, positive angles are moving counterclockwise, and gaining as they go around. Negative angle measures are going clockwise. So they're starting in the same place, but instead of coming around going up to the 90, to the 80, to the 270, and back to the 360, it's doing the exact reverse of that. So it says negative 280. You're going to start here and move clockwise. 90, 180, and 30 more would give you 210. But that is a negative degree there. Okay? So coterminal means something that's equivalent to that 30-degree angle, right? So coterminal. So something that would be coterminal to 30 basically means that you can add another full rotation, one full rotation around the circle, around the unit circle. And there's many possibilities for that answer. So if we added 360, 390 would be coterminal. The initial angle, and sorry, the initial side and the terminal side are in the same place. So 30 would be here. Okay. If we go all the way around the circle, That's 360, and another 30 to get back up to where that originally was, we would have 390. If we did it twice, we'd have 360, another 360 gives us 720, plus the initial 30, which would be 750. Those are examples of coterminal angles to 30. They're equivalent, basically, okay? Equivalent in measure, and for the use of sine, cosine, and tangent, okay? So we're going to go down below, and we're going to practice drawing just some standard angles and where they would be. These don't have to be exact. I'm looking for you to get them in the correct quadrant, okay? So draw an angle of negative 45. That means I should be starting here and coming down. 45 is right in between. Each one of these quadrants is 90 degrees, so it'd be right about here. So that would be a negative 45 angle. 215 might help you to label all of these, especially for a while until we really get used to the unit circle. So I know that it's going to be past my midway point, and it's going to be passed by another 35 degrees. So that would be, this is half, that's a little bit less than half. Okay, I know I'm going counterclockwise because that angle is positive. 405, so if you take 405, a full rotation around the circle is 360. Okay, so that would give me 45 degrees left. So I go all the way around, that's 360, plus another 45 degrees. So that would be a rotation of 405. Ask yourself what that is coterminal to. That would be coterminal to 45 degrees. So anything that would apply to a 45-degree angle would also apply to 405. Okay? All right, so unit circle and radian measure. And we're going to go over in class what we use radian measure for. I've got kind of a neat little explanation as to what radian measure is about. So what I want you, for the purposes of your notes, to understand is that a radian is equal to 180 degrees. Okay, so anytime you have a radian that you're trying to convert to degrees, or degrees that you're converting to radians, that's the conversion that you're going to use. Okay, so for example, if we have 1 radian, that equals 180 degrees. A radian divided by 2 would just be 180 divided by 2, which would be 90. A radian divided by 3 would be 180 divided by 3 would equal 60 degrees. A radian divided by 4 would be 180 divided by 4, which would be 45 degrees. A radian divided by 6, which would be 180 divided by 6, would equal 30 degrees. These are numbers that you're going to need to know. They're going to become very used all the time. You can also have other functions besides just pi over those numbers. I know up until this point pi has meant 3.14, and I'm going to explain to you on Wednesday and Thursday why we use that same measure now for the unit circle and for trigonometry. Okay, a little bit lengthy explanation that I would, not lengthy, but a little bit more involved than I want to do in notes. So I want you to get a glimpse of it first, and then as we talk about it on Wednesday and Thursday, it will make more sense to you. Okay, so how many radians in 1 revolution of the circle? What you do need to know is that when you go out to here, 1 whole revolution, if pi equals 180, then if I go out here, this measure is going to be pi. If I go all the way around, how many degrees are in a circle? I have 360 degrees in a circle. If each pi is worth 180, that means all the way around the circle is worth 2 pi. If I go up to 90 degrees, right, 90 degrees is pi over 2. And then let's figure out 270 degrees. I'll put it over here. 270 degrees. Oops. It's 3/2 over pi, or 3 pi over 2. So if you think about it, this is 0, 1/2, 1, 1.5, and 2. You can look at it that way. Okay, so this would be 3 pi over 2. So there's your concept. And you can flip them around. You can flip that proportion around just depending on which one you need, whether you're converting from radians to degrees or degrees to radians. So go ahead and fill in your chart down here. You've now got the numbers up here. So 180 would be pi. 90 is pi over 2. 270 is 3 pi over 2. Pi radians equals 180 degrees. Okay? So whenever you're doing this, you're just going to multiply by the number of degrees that you have. Sorry, radians that you have. You're going to divide by the degrees that you have. So the easiest way that I do it is I do this. I do 135 divided by 80. Okay, if I'm going to convert 135 degrees to radians. This is all I do. I kind of leave the radians out of it. So 45 can go both into those. So 45 goes into 135 3 times. 45 goes into 180 4 times. And then I stick the pi on top. So that'd be 3 pi over 4. Okay. 240 divided by 180, excuse me. 60 goes into that 4 times and goes into 183 times, so you have 4 pi over 3. If you ever want to check these and double check, you're going to do 4 times 180 divided by 3 and see if that works out. So that's 720 divided by 3, which is 240, which is what we started with. Okay. Your fractions have got to be really good in trigonometry because it's all ratio based. So another way, when I'm converting from radians to back to degrees, one of the things I think of is my ratios that I've got up here. So like I know a pi over 2 is worth 90 degrees. I know pi over 4 is worth 45 degrees. I know that pi over 3 is worth 60 degrees. And I know that pi over 6 is worth 30 degrees. So when I get down to these, what I do is I look at the force and go, every one of those is worth 45 degrees. So I do 45 times 7, which gives me 315 degrees. I know that I'm getting that pi out of there. So the other thing that you can do is do 7 times 180 divided by 4. But if you look and see what happens, 4 goes 180 45 times, and then you're just multiplying those back together, you would get 315. It's just straight conversions. So when I look at this, I think, okay, every third of a pi equals 60 degrees, right? And I only have one of them. So 60 times 1 equals 60 degrees. That's kind of how I look at them. I'm just kind of that making change thing again. Okay, third of a pi is worth 60. I only have one of them. I have 60 degrees. Every fourth of a pi is worth 45. I have 7 of them, which means I have 7 times 45, which gives me 315. We're going to do quite a bit of practice on converting radians to degrees and degrees to radians. So we'll be working with that more on Wednesday and Thursday. Okay, so the unit circle below. This is what we are going to be working on in class. It's extremely important that you remember the unit circle. We'll get into more in depth on why the unit circle is used. You need to know your measures in radians and degrees. It's actually a little bit, I'm not sure which one's easier. I think they're both fairly easy. So you're going to at least start with your degrees. So 0 degrees, you know that's 90 degrees, 180, and 270. If you're going to put the radians in, this would be 0, pi over 2, pi, 3 pi over 2, and this would be around, it would be at 2 pi again. Okay? 0 and 360 are interchangeable. Okay? Now, if I was only to look at just the coordinates for this point, your coordinates on the coordinate plane are always cosine. Sorry, I'm not sure how much of that skipped because it was on pause and I didn't realize it. So, if I know the radius of my circle is 1, then I can go in and put my coordinates. I have 1, 0, 0, 1, -1, 0, and 0, -1. Okay? The way that I look at this is always your cosine and sine in the unit circle. So instead of x and y, it's kind of the equivalent of your input and your output, but your cosine comes first, your sine comes second. So if I'm going to go from 1 to 0, I'm going downhill, right? So I've got a decrease, and I'm just counting down 3, 2, 1. to get from 0 to 1, I would count up. So that'd be square root of 1 over 2, square root of 2 over 2, square root of 3 over 2. Okay? These degrees would be your 30, 45, and 60. Okay? And you can do that for each one of these. Take 90, add 30, 45, and 60. So I would have 120, 135, and 150. Okay? That takes us to 180 here. Keep going with your degrees. So 180 plus 30 would be 210. Add another 15, 225. Add another 15, you get 240. Now you're back at 270. Finish it out. 270 plus 30 is 300. 315 and 330. Okay? These coordinate points here are going to be the same in every single quadrant. The only thing that changes about them is whether they are positive or negative. So you have to think about in quadrant 1, everything is positive, positive. Okay? Anything on our x-axis is positive, our y-axis is negative. So for us in the unit circle, all of our cosines are positive, our sines are positive. Here, your cosines are negative and your sines are positive. In quadrant 3, both are negative. Think about when you plotted things in this, you would go negative and then negative. So these are negative, negative. Here, you have positive, negative. So exactly the same coordinates, they're just going to change their signs here. So remembering those signs is going to be really important, but you're still counting down or up as the case may be. Let's start with our cosines. We're going from 0 to 1. So it'd be square root of 1, square root of 2, square root of 3. Except now, because we're going to the left, you have negative of all those, and they're still over 2. All of our signs are still positive. So now we're counting, all of our signs are going from 1 to 0, so we're counting down. So that would be square root of 3 over 2, square root of 2 over 2, and square root of 1 over 2. So if you kind of see what's going on there, they're the same. It's just that now we have got mirror reflections of each other. Okay? So here you'd have the same numbers. You've got counting from negative 1 to 0, you go down 3, 2, 1. So it's these, but now you're reflecting over the x-axis. And here, both of your sides are going to be negative. So you'd have negative square root of 3 over 2, and negative square root of 1 over 2, which is just 1, obviously. Negative square root of 2 over 2, negative square root of 2 over 2, and negative square root of 1 over 2, and negative square root of 3 over 2. Okay? Going back up, if you want to look at it, it's just this reflecting now. The only difference is that all of our signs are going to be negative. So we still would have, going from 1 down to 0, you'd have to count down 3, 2, 1. So square root of 3, square root of 2, square root of 1, over 2, over 2, over 2. And now our signs are going to go 0 up to 1. But now these are all negative, so negative square root of 1 over 2, negative square root of 2 over 2, negative square root of 3 over 2. Okay? We already did the degree values. Let's go in and do, so every 30 degree, remember what we said. Let's go down for a minute and remember what we talked about a minute ago. So pi over 2s are worth 90. 90 degrees. Pi over 3s is 180 divided by 3 is worth 60 degrees. Pi over 4s are worth 45 degrees. Pi over 6 is worth 30 degrees. So the way that I do this is you can start with your 30 degrees and count. There's one 30 degree, another 60 would be 2, 3, 4, 5, 6. 30 degrees gets you to 180. So 30, that's a pi over 6. This would be 2 pi over 6, which reduces to pi over 3. This would be 3 pi over 6, which is pi over 2, which we already knew. This would be 4 pi over 6, which would be 2 pi over 3. And this would be 5 pi over 6. And this would be 6 pi over 6, or just pi. Okay? Keep going. You'd have 7 pi over 6. 8 pi over 6, which reduces to 4 pi over 3. And 9 pi over 6, which reduces to 3 pi over 2, which we had from the original. Keep going around. 10 pi over 6, which reduces to 5 pi over 3. And 11 pi over 6. And then 12 pi over 6, which would be what? That would be 2 pi, which is what we said we have there. So if you want to go around and check now with your pi to the thirds, every 60 degrees is pi over 3. So we should be able to count. There's 1, there's 2, there's 3 pi over 3, which would just be pi. There's 4 pi over 3, 5 pi over 3, and 6 pi over 3, which would just be 2. The 45s are kind of easy because those are going to be pi over 4. So you'd have 1 pi over 4, 2 pi over 4, which reduces to pi over 2, 3 pi over 4, and this would be 4 pi over 4, or just 4. Or sorry, excuse me, just pi. Keep going, you would have 5 pi over 4, 6 pi over 4, which still reduces to 3 halves, and 7 pi over 4. So those are your radian measures. Okay, it is fair game on a test for me to ask you any of those and to fill in the unit circle. You're going to repeatedly fill in the unit circle over and over and over. So one of the things that I will give you on Wednesday, we're going to do this in class together, is something that looks like this. Okay, and that is a fill in the unit circle. Okay, and we're going to go one by one and fill in degrees, radians, and our coordinates all around the unit circle. And this is something you're going to get very familiar with. Once we have that, that's when we can start adding in our triangles and seeing those relationships. So for example, that will give us a 30, 60, 90 triangle. This will give us a 45, 45 triangle. We'll see it right there. And here's another 30, 60, 90 triangle. Okay? All right, that's it for your notes. Make sure you get those done. Bring them to class on Wednesday and Thursday. And then it is unit circle time. Thank you.